Gentlemen, welcome back to the shop. Today we are looking at a very interesting piece of technology which is only possible due to the paragon of materials. That's right, tungsten carbide, colloquially known around here as Kunstein tongue glide. It is the paragon of materials, high temp, hard as a coffin nail, tough, and something something. This is a flow drill, also known as a friction drill, and contrary to Adam and Steve in the Garden of Eden, we want heavy friction while we're drilling, because what happens is, as any blacksmith will tell you, as the metal heats up it becomes more and more like clay. We're actually going to drill a hole not by mechanical cutting but by pressure and friction. We're going to flow the metal out of the hole. Now, it seems rather inefficient. Why would you want to melt a hole through metal when you could mechanically cut it? Well, my friends, it's because thin-walled section is tough to thread and put a bolt in. It doesn't hold up very well. Case in point, this little guy, if you were to just thread that, it wouldn't hold for shit. Your bolts would pull right out. So, by flow drilling, we can pretend this is actually thicker material than it is. Correct. Beauty. Now, tungsten carbide is hard. It'll cut any rock out there, with the exception, of course, of diamond. Now, we use diamond to dress tungsten carbide, and it's just slightly less hard than silicon carbide, but it's a carbide, and it's the most useful material in the machine shop for cutting. And part of the beauty of it is it can handle extreme temperatures without going soft. It doesn't go soft at all. It stays hard, even at red hot. It doesn't act so much as a metal as it does a ceramic, and it's right in the name, cemented carbide. So what happens is they take tungsten carbide particles and they cement them at temperature. They put them in a mold, they make the shape, and those are green. Then they cook them, and then they sinter them. That is, the grains of the nickel or whatever the matrix is that the cemented carbide is in grows together, and it holds it together like a cement. I do have some bigger tooling here. This is for 1/2 inch. I don't know if the Bridgeport milling machine is going to have the energy, the power to, pierce this hole, but I'm going to try. Just put the head of it in anyway, and only for a minute. This tool looks round to the naked eye, but if you have a real good look at it, it's actually 4 lobes. And if you feel it, you can feel it's 4 lobes. It's not perfectly round, so that is a pain right in the ass to machine. You'd have to grind that in a nice surface finish. You'd have to diamond grind that on a cam grinder. There's a fair bit of work that went into that. Well, one of the things I noticed when you're buying tools from China, the carbide stuff is always pretty good. Like, it looks good, it's not all gnarly, and then the high-speed steel stuff is just horrific. Case in point, here's a cheap carbide end mill, the cheapest I could get. 4 flute. And not too horrific. It's good. It looks, to my untrained eye, looks nice. Shank is nice, it looks indexable. It's even got some sort of vacuum coating on there. This meat hook abortion. Look at the thing. Ground. Yeah, ugh, nasty. And look at the cutting edges, all rolled over on the grind, and real, just nasty, nasty grind. Chunks taken out of it, like that's fresh, brand new. loaded right full of Cosmoline, stinky. Anyway, I thought it's interesting that they haven't figured out a way to make super shitty tungsten carbide yet. Here's Bridgeport Milling Machine back gear in your eye. Well, we're through. Little bit big for the Bridgeport milling machine. It just keeps better and better getting. An amazing property of Tungsten Tongue Glide is its thermal characteristics. It barely transfers any heat. And its thermal expansion is extremely low. So that makes for stuff that doesn't blow up in your face when you do stupid shit like I'm doing. Beauty. Now look at the cross section of that HSST hollow structural steel tubing. 1/8 wall. You'd get a thread, maybe a thread and a half in there. And now you're going to get at least twice that, if not 2.5 times that. So if you're looking to bolt thin wall sections together, flow drilling is the way to go. Yeah, beauty. That would also be the way to go for fluid connections for non-pressurized, non-pressure vessels made out of thin walled section. Wink, wink, nudge, nudge. Not that you'd ever, ever, ever do that. Ever. We saw the 1/4 of an inch, no problem. The 1/2 inch, kind of sketchy. I think 3/8 is going to be the cock for dolly here. Goldilocks effect. It's going to be just right. Uh-oh. Oh no. Let's go. Woo! I had that brake applied. Woo! We are on an inexorable path to a destroyed Bridgeport milling machine, but anything for the cause, am I right? Too aggressive. Too aggressive. It welded itself in there. And then I let it stop. And it froze in there and then shattered into a million little bits. Look at that. Fair warning, what? Home shop machining level up. We just got the head of her in there. Focus, you fuck. And I guess the deal is, once you get your tool in there, don't let her cool down. Because that's what happens. Break your dink right off. Son of a diddly. Okay. Interesting anyway. Some nice experiments. Thanks for joining me for a chuckle in the shop, and keep your dick in a vice. Ooh, you tell me, does that or does that not look like the beginnings of a proper friction stir welding tool?